Hello, Algebra 2 student. And what we're going to do here is we're going to work on a couple of problems from this set of problems here. It was requested. And so I am going to go ahead and show you these two problems from this section. Those problems will be numbers 2 and 6. And let me just show you how this is done. So first, number 2, it says f over h of x. Remember, that means that we are doing f of x over h of x. Okay, that's what that means. So, as I might have mentioned before, if you've ever heard me teach about this, is that when you have division, it's actually pretty simple because all you're basically doing is just replacing those functions with what they're equal to. So for number 2, in this problem here, for f of x, it says f of x is 2x squared minus 9x plus 2. Okay, so that's f of x. And we just, write that in. And then h of x is x squared minus 4. Okay? And basically, at this point, you can't really simplify it. In fact, I don't think you can simplify it. We could do division and stuff later, but at this point in the day, at this point in time, we're not really doing that. So yeah, that's it. It's just going to be that. Okay, so that is actually the simplified answer that we'll take for this problem for number 2. Okay. All right, then for number 6, it says g times h of x. So what does that mean? That means, again, it's going to be g of x times h of x. Now, what I'm going to do is go ahead and fill in what those are, and then I'll zoom in. So g of x is 1 minus 6x. H of x is x squared minus 4. Okay? So I've written down those two functions. Now, what we have here is we have two expressions that are getting multiplied. Okay? And so whenever you have two expressions that are multiplied, that means you're now going to get ready to do the box method. So I'm going to draw my box. Okay? And there's my box. And I'm going to put in 4 windows, basically, because it's 2 terms by 2 terms. Okay? Yeah, it's a slanted line, but it's okay. Still straight. There we go. All right. And maybe I can move this one. Or not. Okay, fine. All right. So what I'm going to do is I'm going to put 1 minus 6x across the way on the top. And then the side is going to be x squared minus 4 down the side. And now we're just going to multiply to get into the boxes. So therefore, what we're going to do is we're going to have x squared times 1. So x squared times 1 is going to be x squared. Negative 6x times x squared is negative 6x to the third power. 1 times negative 4 is going to be negative 4. And then negative 6x times negative 4. Negative 6x times negative 4 is positive 24. And did I miss something here? 24x. Excuse me. Yes, 24x. Okay. All right. And if you'll notice, there are no like terms in the boxes. So basically, all that means is that we can write this in order from least or highest exponent to lowest exponent. So basically, it's going to be negative 6x to the third. Then it's going to be plus x squared. Then it's going to be plus 24x. And then it's going to be minus 4. So that will be the expression simplified for number 6. All right, and so now we're going to go down here to number 6 on another assignment here, where they ask you to do is to find the domain and the range, and then determine if it's a function or not. Okay, so whenever you have a graph that looks like this, what you're going to basically do is you're going to basically put points, show dots where they are located. And so, for example, I know that there's a dot right here. I know there's a dot right here. I know there's a dot right here. I know there's a dot right here. Okay, those are important points because we have our leftmost point, our rightmost point, our highest point, our lowest point. Now, identifying where these are. This point here is at, let's see, 1, 2, 3. So it'll be negative 3, 0. This point up here is going to be 1, comma 2. This point right here is going to be 1, 2, 3, comma, -2. And this point down here is going to be 1, 1, 2, 3, 4. So -1, -4. Okay? Those are our vertices of this, what appears to be a square. Okay, it might not be a square, it might be a rectangle, but that's what appears to be a square. All right? Whenever points are connected, we do not list the numbers of the domain and range. We simply use inequalities. And so what we'll do here is on the domain, remember, is x, so we're going to do less than x, less than. For range, we'll do less than y, less than. And then what we'll do is we'll determine what the lowest x is and the highest x is on this graph. Well, looking at the leftmost side, looking at all my x's, I have -3, +1, -1, and +3. So out of those four numbers, -3 has to be the lowest. Okay, and the highest x, based on what we just underlined, is going to be +3. And since both of them are points, none of them are open circles, we can go ahead and write down the fact that this should be a less than or equal to, and this should be a less than or equal to. All right, so that takes care of the domain. We'll do the same thing for the range. We'll look at the y's now, and we determine which one is the lowest, highest for that. So here's -4, here's 0, here's +2, and here's -2. So what's the lowest y coordinate? It's going to be -4. So I'm going to put -4 on the left side. And then what's the highest y coordinate? +2. Put that up there. And then, again, because they're both dots, they're both closed circles, we're going to go in and put the equal sign on each sign here. Okay? And then finally, what we have to do is we have to determine if we have a function. Well, the best thing to do on a graph is I'm going to attempt to draw a vertical line. So let's see if this will work. Let's see here. Try and get this to work for us. Okay, it's not going to draw for us, huh? Maybe if I draw over here. There we go. All right, I'm going to erase this one over here. Yeah. All right, and so basically what we can do is that with the vertical line, I can basically take this line, if I can move it. There we go. Yeah, and I'm gonna use that as my for my vertical line test. Anytime that this line touches the graph more than once, then that's automatically going to be not a function. If you look right here, it's touching the square or the rectangle, whatever it is, twice in two different places. See, it's touching it here. If I can get my marker here, and here. Okay, and that already messes it up. So therefore, this is not a function. Okay, and we say it's not a function because it fails the vertical line test. Okay. All right, and that's basically it. Thank you so much for watching. I hope this helps you complete your assignment. All right, and take care.